guys, today I am going to discuss about mathematics chapter 1 class 10 real number. So let's start it. In this chapter we have to discuss about mainly 3-4 topics in which there are some. Number one, there are two theorems. Number one, fundamental theorem of arithmetics, and number two, Euclid division theorem. After that we will talk about HCF and LCM. And after that we will talk about what? Irrational number and also some applications on irrational number. Okay, now I'm going to discuss about first of all real number. Real number. So what is real number? Real number is basically combination of rational number and irrational number. So it is a combination of rational number and irrational number, and we have discussed about rational number in the last class of maths. What is irrational number? Irrational number is root 2, root 3, root 4, and if we see about the decimal expansion of irrational number, it is non-terminating and non-recurring. Non-terminating, non-recurring means example 0.1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1. Sorry. So you can clearly see here that the number of 1 is increasing. So this is not non-terminating and not recurring. So this is irrational number. If we go towards the definition of irrational number, what will be the definition of irrational number? Irrational number, it is any number which cannot be, which can't be expressed in form of a by b, where a and b are integer and b is not equal to 0. So this is the definition of irrational number. Any number which cannot be expressed in the form of a by b, and here a and b are integers and b is not equal to 0. These are conditions. Suppose we see the example, and you have to see that the decimal expansion of irrational number is non-terminating, non-recurring, and the rational number and the decimal expansion of rational number, what? It is either recurring, either terminating. So we have discussed this in last video. Okay, now I'm going to discuss about there are two algorithms. Number one, Euclid division algorithm, and number two by what? Number two was fundamental theorem of arithmetics. बेसिकली क्या है कि यूक्लिड डिवीजन एल्गोरिथम में हम ये पढ़ते हैं कि कोई भी एक नंबर है, suppose there is a number a which is divided by b, then leave some remainder r. So here this is the basic formula of division, that any number a is divided by b and leaves remainder r. So here what will happen? Here happen that r should always be lesser than b. This is the main thing in the Euclid division algorithm, that if a is divided by b and leaves remainder r, then r should always be lesser than b. This is the main Euclid division algorithm. Now You will see a fundamental theorem of arithmetics. Fundamental theorem of arithmetics, it says that any composite number every composite number have a unique set of every composite number have a unique set of every composite number have a unique set of factors and it can be expressed by multiplication of all those prime factors. Prime factors. Basically, here it will be prime factors. Fundamental theorem of arithmetic says that every composite number have a unique set of prime factors, and it can be expressed by multiplication of all the prime factors. So, here main thing is that it is the main word is this unique. Suppose example, I am taking example here. Suppose there is a number 160. Okay, 160 is a number. How can we factorize it? After factorization, it can be written as 2 into 2, 2 into 2 into 2, 2 into 2 into 2, 4 to the 8, 20, 2 into 2 into 5. So like 1, 2, 3, 4, 5, 6, 2 to the power 5, and basically 2 to the power 5 into 5. 2 to the 4 to the 8 to 16 to 22 5 160. 2 to the power 5 into 5. This is 160. So what we can here see that if we can also write it as 2 into 80. We can also write it as 2 into 80. So, but this is not a prime factorization of 160. We can only write this as prime factorization of 160. And here's there is a line written that we are supposing all the possible orders of writing factor. Same. Supposing all the possible orders of writing factors same. Here it normally means that suppose we have written here 2 to the power 5 into 5. So it can also be written as 5 into 2 to the power 5. It can also be written as 5 into 2 to the power 3 into 2 to the power 2. So we are supposing all these are same. After that we can say that every composite number have a unique set of prime factors. Now take a screenshot of this. I think you know what is composite number. So what is composite number? What is composite number? First of all, recall in your mind. Now I am going to now I am going to say it that what is composite number. So composite number is any number which have any prime factor. Other than 1. Okay, any number which have any prime factor other than 1. Now what is prime factor? What is prime factor? Prime factor is any number which have not any factor, which have not any factor other than 1, other than on this is prime factor. What is composite number? What is prime factor? I think you are clear now. What is composite number and what is prime factor? Now I am going to tell you about the application of what? Application of fundamental theorem of arithmetic. There are many applications of fundamental theorem of arithmetic. First application is HCF and LCM. So how can we find the HCF and LCM by prime factorization method? I think you have read it in class 9, but I will recall you here. And how will we find HCF and LCM by fundamental theory of arithmetic or by prime factorization method? How can you find? Suppose we have to find LCM and HCF of 16 and 32. We have to find LCM and HCF of 16 and 32. So how can you find the LCM and HCF of 16 and 32? First of all, what we do? First of all, we do the prime factorization of 16 and 32. First of all, we do prime factorization of 16. So what will be the prime factorization of 16? The prime factorization of 16 will be 2 into 2 into 2 into 2. This is a prime factorization of 16. What will be the prime factorization of 32? It will be 2 into 2 into 2 into 2 into 2. Basically, this is 2 to the power 4, this is 2 to the power 5. Now, how I find HCF? How I find HCF? HCF is the highest common factor. So, what is highest common factor here? Common. Which is the highest number which is common here? This is common here. You can clearly see that 2 into 2 into 2 into 2. There is 4 to here. There is 5 to here. So, what is common? There is 4 to common. 4 to common. 1, 2, 3, 4. 1, 2, 3, 4. 4 to is common in both. So, here HCF will be 2 into 2 into 2 into 2. Okay. This will be HCF here. Clear? So, after that, we will find LCM. So, how will we find LCM? We will find LCM that we will observe both factors of both numbers. We will observe factors of both numbers. And what will we do after that? We will see that in which number there is more exponential power of same factor. More exponential power of same factor. And the number in which there is more exponential power of same factor, we will consider those factors. Okay. Example. Yeah, here you can see 80 to the power 4. 80 to the power 5. So the exponential power is here more in 32, which is to the power 5. Okay. And it is less in 16, which is to the power 4. So we will take LCM as 2 to the power 5. I suppose that you clear it, you will still clear it, but I will let you clear from another example, some more example. Okay. 2 to the power 5. So here LCM will be 32 and LCM will be 16. So let me take another example. Suppose here it is 6. We have to find LCM and HCF of 16 and 6. So first of all, do prime factorization of 6. Prime factorization of 6 will be 2 to the power 1 into 3 to the power 1. And prime factorization of 16, it will be 2 to the power 4. So now how can we find HCF? First of all, HCF. HCF is, you can clearly see HCF is highest common factor. So what is common in both? Only 2 to the power 1 is common. So HCF will be 2 to the power 1. Okay. Now we will find LCM. In LCM, what we do? You will see that suppose they are you are seeing there are two types of factor here. Number 1 is 2 and number 2 is 3. Number 1 is 2 and number 2 is 3. So you can clearly say right here 30 into 3 to the power 0, 2 to the power 4 into 3 to the power 0, and 2 to the power 1 into 3 to the power 1. Now we have to compare that in both number, in which factor there is more exponential power. Example, you can see that here if you compare 2 in the both case, so in 16 there is 2 to the power 4 which is more. So in LCM we will take 2 to the power 4 into, I mean in the case of 3 you can see that in 6 there is more exponential power of 3 which is 3 to the power 1, here 3 to the power 0. So 3 to the power 1 we will take 3 to the power 1 here, और ऐसे निकल जाएगा हमारा LCM. कितना हो जाएगा LCM? 16 into 3, it will be 48. Now there is a method to check that your LCM and HCF is right or wrong. So there is a rule that HCF of x and y into LCM of x and y is equal to the value of x into y. It will be equal to the multiplication of that number value. So we can check here that 16 into 6 is equal to 96. And what is the LCM here? LCM here is 48 and HCF is 2. HCF is 2. So we can also find here 96. So we are right with our solution. So this is a formula, this is a method to check the LCM and HCF. Now I am going to discuss about three numbers. How to find LCM and HCF of three numbers. Example, you have to find LCM and HCF of what? 6, 16 and 50. You have to find LCM and HCF of 6, 16 and 50. So what is prime factorization of 6? Prime factorization of 6 will be 2 to the power 1 into 3 to the power 1. Prime factorization of 16 will be 2 to the power 4. And prime factorization of 50 will be 2 into 5 into 5. So here it is 2 into 5 to the power 2. 2 into 5 to the power 2. Now we have to find HCF of all three numbers. So what is common in these three numbers? What is common in these three numbers? It is 2 to the power 1, to the power 4 and to the power 1. So you can clearly say that 2 to the power 1 is common in all three numbers. So the highest common factor is 2 to the power 1 equal to 2. Highest common factor will be 2. Okay. Now we find LCM. How to find LCM? For finding LCM, we can clearly see here that what is the maximum exponential of 2 in all the three numbers? It is 2 to the power 4. So LCM may first of we will write 2 to the power 4, and we will find now another factor which is appearing here. It is 3. So you can clearly see here, and it can be written as 3 to the power 0. Here 3 to the power 0. Okay guys, so maximum it is 3 to the power 1, 3 to the power 1, and you can also see here 5 to the power 2. So you can write here it is 5 to the power 0 and it is 5 to the power 0. So what is maximum? Comparing this and this, maximum is 5 to the power 2. Say 5 to the power 2. So what is LCM here? It is 16 into 3 into 25. Now you can also which is I think 48 into 25. Now we have to check here. The checking process is that we have to LCM into HCF will be equal to 6 into 16 into 50. 6 into 16 into 50. So LCM into HCF will become, HCF is 2 and LCM is 48 into 25. Yes, and here it is 6 into 16 into 50. So by evaluating, you can clearly see that these two is not equal. These two is clearly not equal. So from this you can see that this is not equal. That the checking method which is C here, it is not here true. So this is not a process of finding HCF if LCM is given in 3 numbers. Suppose in 2 numbers certificate if LCM is given in 2 numbers, question if LCM is given and whole 2 number is given, 2 number and LCM is given. So what we can do? We can easily find HCF. We can easily find HCF by x into y by LCM. But in 3 number case, this is 2 number case. In 3 number case, we cannot find by this method. Okay. So in that 3 number, there is another method to find if HCF is given and we have to find LCM. We can find it easily. There is formula which is given in book also. You can go through. But मैं यहाँ बता दे रहा हूँ. We have to find suppose HCF of x, y and z. So how can we find HCF of x, y and z? So what we can do here? First of all, we will multiply x into y into z. Okay. After we multiply, so HCF we have to find. So LCM will be given. LCM will be given. So x into y into z into LCM of x, y, z, and it is divided by what? It is divided by LCM of x, y into LCM of y, z into LCM of x, z. So this is a process to find HCF of 3 numbers if the 3 number and LCM of that number is given. So you can easily find HCF. Similarly, how to find LCM? For finding LCM of x, y and z, what we can do? We can x into y into z into HCF of x, y, z divided by HCF of x, y into HCF of y, z into HCF of x, z. So you can clearly see here that you can find LCM of 3 numbers if HCF of 3 numbers and the 3 numbers are given. Increasing in the topic. So what we have to do? We have to now visit irrational number. Irrational number. Okay. So we have to visit irrational number. So what is irrational number? We see in the videos in शुरू में देखा हमने √2, √3, √5. These are irrational number. So you know that what is irrational number. Now we have to how to prove irrational number. That some number is irrational number. How to that question example. What is question? Question that to prove that √3 is an irrational number. So how to prove that √3 is a irrational number? So we can clearly prove. How? So we have to prove that √3 is a irrational number. So we can clearly take √3 as a rational number. We can take let √3 is equal to a rational number. We can take √3 as a rational number. So if it is a rational number, you can write it as √3 is equal to a by b. Here a and b don't have any common factor. Surely a and b don't have any common factor, which is a property of rational number. So root 3 equal to a by b. So here root 3 into b will become a. The squaring on both sides, it will become 3b square is equal to a square. It will become 3b square is equal to a square. Now we have to read a theorem, which are also application of fundamental theorem of arithmetics, that if p is any prime factor, or if no, let p is any prime factor, let p be any prime factor, then if p divides a square, if p divides a square, then p will also divide a. This is basically application of fundamental theorem of arithmetic, that if p divides a square, तो p जो है वो a को भी divide करेगा. This is a truth, and there is a condition that p is any prime factor. So here you can see that by this equation what you can see, 3b square equal to a square. It means that 3 divides a square. 3 divides a square. You clearly see that 3 divides a square. So, and if 3 divides a square, you can clearly see that 3 is a prime factor. So if 3 divides a square, then 3 will also divide a. If 3 divides a square, then 3 will also divide a. Now you can see here that if 3 divides a square, then 3 will also divide a. Now what happens? If 3 divide a, if 3 divide a, then a will be equal to 3c. A will be equal to 3c. Squaring on both sides, a square will become 9c square. A square will become 9c square, and we know that a square is equal to 3b square. So 3b square equal to 9c square. 3b square equal to 9c square. So I think there should be clear till guys. Let root 3 equal to rational number, because we have to prove that root 3 is an irrational number. So we can take that root 3 is a rational number. So root 3 is equal to a by b, and a b don't have any common factor. So root 3 is equal to a. So 3b square, squaring on both sides, 3b square is equal to a square, and 3 divides a square, so 3 will also divide a. You clearly see here 3 is a factor of a square. 3 is a factor of a square, so 3 divides a square, so 3 will also divide a. And 3 divide a, so we can take as a equal to 3c. Here we can see that 3 divide a. So squaring on both sides, again a square equal to 9c square, and we know that from this here that a square equal to 3b square. So 3b square equal to 9c square. We can clearly cut here by 3. So b square will become 3c square. Now from here you can say that 3 divides b square. 3 divides b square. So 3 will also divide. 3 will also divide b. If 3 divides b square, then 3 will also divide b. So you can see here that 3 divide a, 3 divide b, but our assumption was what? Our assumption was that a and b don't have any common factor. A and b don't have any common factor, but here you can see that a and b both have 3 as a common factor, which is not possible, because our assumption was that a and b don't have any common factor, and hence for this reason our assumption will be wrong, and so our assumption was wrong. So we can say that root 3 is a. So you can write here that our and hence our assumption was wrong. Our assumption was wrong. Hence root 3 is a irrational number. Hence root 3 our assumption was wrong, so root 3 is an irrational number. Similarly, you can see also prove that, or you can also prove root 3 as a irrational number. You can also prove root 2 as a irrational number, root 5 as a irrational number. Now there is also another question that we know that the addition and subtraction of any rational and irrational number is always a irrational number. Means example, you have taken 3 plus root 5. So 3 plus root 5, 3 minus root 5, all these will always be irrational number. It cannot be rational number in any case. So we have to prove that root 3 plus root 5 is a irrational number. How to prove? Prove that root 3 plus root 5 is a irrational number. Prove that 3 plus root 5 is a irrational. It is an irrational number. How can I prove that root 3 plus root 5 is a irrational number? So similarly, you have to take let 3 plus root 5 as a rational number. Let 3 plus root 5 as a rational number. So what will happen again? 3 plus root 5 we can write it as a 3 plus root 5 is equal to a by b. Here a and b are purely an integer. A and b are integers. Because this is a definition of rational number, that in rational number, if a by b, then a and b will be integer, always be integer. So 3 plus root 5 is equal to a by b. So root 5 will be equal to what? A by b minus 3. So root 5 is equal to what? A minus 3b by b. Now you can see here that a is integer, b is integer, and because a and b are integer, so surely this will be a rational number. Surely this will be a rational number. Why? Suppose I am taking that a is equal to 1 and b is equal to 2. So what will happen here? 1 minus 3 into 2 by 2. It will be 1 minus 6, means minus 5 by 2, which is obviously a rational number. Minus 5 by 2 is a rational number. It was example for see that it will be a rational number in any case. You can put also another value to prove it. So root 5 is equal to a minus 3 by b. So we know that a minus 3 by b is a rational number. But we also know that root 5 is an irrational number. We also know that root 5 is an irrational number. So our assumption becomes wrong. That root 5 is that 3 plus root 5 is a rational number. So our assumption, similarly we can write here, our assumption was wrong. And hence 3 plus root 5 is a rational number. Hence 3 plus root 5 is a rational number. Now take a screenshot of this. Now I am going to do another type of question here. There was a question that prove that 3 root 5 is an irrational number. Now in previous question I say you that It is a fix that if there is sum or difference of rational and irrational number, then there will always be a irrational number. It is sure, for sure. But here, root 3 root 5 means multiplication of rational and irrational number. It can be rational or irrational. It depends on situation. So here we have to prove that 3 root 5 is an irrational number. How can we prove it? We can prove it that similarly take root 3 root 5 as a let it as a rational number. Let it as a rational number. So 3 root 5 will be equal to 3 root 5 will be equal to a by b. Sure. So root 5 will become a by 3b. But we take it as a and b, which we should know that a and b both are always integer. We know that a and b are integer. Hence a by 3b will always be a rational number. A by 3b will be a rational number, but we know that root 35 is an irrational number. Hence these both cannot be equal in any case. So we have to write that our assumption was wrong. Our assumption was wrong. And hence 3 root 5 is a rational. 3 root 5 is an irrational number. So thank you guys. I read this. I have teach you through this in video. In next video, I will discuss about some questions in NCERT, and also I will teach you another topic. Thanks guys. Best of luck.